Good evening, students. Today we will discuss about binary search technique. As you know, there are two type of techniques, or two type of search technique: linear search and binary search. So, binary search technique starts the searching from the middle index, and if the number is available on the middle, it's okay. Otherwise, after middle, it goes either to the left side or right side. That means it divides the array into two halves, and after one comparison, it compares the number in any one half, either left half or right half. Okay. So we'll discuss binary search according to the example. As you know, in binary search is applicable only on the sorted array. Means given the array in ascending order or in descending order. So let us take this example. Here 14 numbers are there in ascending order. In binary search, the first index we consider as a lower boundary, and the last index of the array we consider as a upper boundary. Like here 14 elements are there in ascending order, so 0 will be considered as lower boundary and 13 is the upper boundary. Now let us search any number. Suppose if I want to search 20 in this array, whether 20 is present or not, using binary search technique. So firstly we will find the step number 1, we will find the mid. Lower boundary is 0, upper boundary is 13. So 0 plus 13 by 2. 13 by 2 is 6, as you know, integer division. So first time, this is the mid index. That means the number which will be compared on the middle is 14. And we are searching what? 20. That means the answer is not available on the middle index. Desired answer is not available. So then, because 20, the number which we are searching is bigger than 14, that means now we will continue searching only in the right side. So how to go right side? For going to right side, we have to change this lower boundary. Because for right side, the upper boundary will remain same. Only the lower boundary will begin from this place. That means middle plus 1. And suppose in case if you have to come left side, so in that case lower boundary will remain same and the upper boundary will be mid minus 1. Okay. So here, because we are going right side, the searching number is present on the right side. So which value will be updated? Lower boundary. Lower boundary will become mid plus 1. That means that now the lower boundary is set. Now in second step, because now lower boundary is 7 and mid upper boundary is 13. So the mid is 7 plus 13 by 2. That means 20 by 2. That is 10. That means second time the mid is here. So which number will be compared here? 28 is available and we are searching which number? 20. So again the number is not found on the middle index. So now you can see here 20 is available in the left side of 28. That means the next search will be only in this area. So for this we have to change the upper boundary. So the upper boundary will be updated mid minus 1. Currently mid is 10, upper boundary will be 9. So now the lower boundary is 7 and upper boundary is 9. So in next round, the mid will be lower boundary plus upper boundary by 2. 7 plus 9, 16 by 2, that is 8. Now the next mid is here and this time 20 is available. So that means the number is present. So you can see like this way the binary search we can perform. So this is the technique. Now let us write the program of binary search. If we want to search a particular number using binary search, so program is here. Import java.util class binary ascending. This I am making for ascending. There are two programs, one is for ascending order and one is for descending order. Void main. Now scanner object. Now we have to make array of size 14 just according to this. So int a square bracket new int 14 Now we'll take the input. What variables are required in the program? One loop variable, then one counter variable is required. We need lower boundary. If the size of array is 14, then the lower boundary will be 0. Upper boundary is always size minus 1. So here, according to this example, upper boundary is 13 and mid and one variable, the number that is to be searched. So enter elements. And loop is required for I equal to 0, I less than 14, I plus plus, and A of I is equal to C dot next identity. Now we have to input the number that is to be searched. So enter number to be searched. S. Now we'll start binary search. For binary search, the condition is while LB is less or equal to UB. What is the meaning? As you can see here, LB is at 0 and UB is at 13. Okay. After comparing the number on middle, either we have to increase LB, or we have to decrease UB. So if LB is less or equal to UB, it means that there is a possibility the number is present. When LB will exceed UB, it means that the number is not possible in the array. So while LB less or equal to UB, then mid we will find here, mid is equal to LB plus UB by 2. The number will be compared on middle index. So if A of mid is equal to that searching number, we can display the message number is present. If you want to print its index also, so mid will be the index. Number is present at index what? Mid. We will use the counter variable if a number is found and then apply the break. So this is one condition. This is one condition. So after that another condition, else if A of mid is less than S. Okay, that means like here you have seen we are searching 20 and A of mid is 14. That means we have to go right side. So when the middle element is smaller than the searching element, we have to go right side. So how we go right side? By changing the lower boundary. Lower boundary will become mid plus 1. And the last condition means if the number is left side. Suppose if number is left side, so you have to update upper boundary, that will be mid minus 1. So now loop is closed. So total 3 conditions are there. If the number is available on middle, so we will give a message number is present at index mid, counter is increased and break. Else if lower boundary is equal to mid plus 1, means if the number is right side, so we will update lower boundary. Else upper boundary is mid minus 1. If number is left side, so we will update upper boundary. And outside the loop, if after completing this loop also counter is 0, it means that the number is not 1. Number is not present. End of main, end of class. So this is the binary search technique. I hope it is clear to you.